Let's do a little investigation about negative exponents. If we have a power of 2 to the 4th power, 2 is our base, 4 is our exponent, so 2 would be multiplied by itself 4 times, or 2 times 2 times 2 times 2. When I type this into my calculator, I get 16. So 2 to the 4th is equal to 16. 2 to the 3rd would be 1 less 2. So 2 times 2 times 2, which is 8. 2 squared would be just 2 2's, which is 4. 2 to the 1st power is just 2. And then we move down to 2 to the 0. And that can be where a challenge kind of hits us. So let's go back and evaluate what is the pattern here to get from 16 down to the next one, from 8 down to the next one. There should be a pattern that can be used no matter which level I'm going to. And that pattern is that each time we are dividing by 2. And we can see that here. If I took 2 to the 4th and I divided it by 2, that would mean I'm taking one of these 2's away. That's how we get 2 times 2 times 2. If I take one of those 2's away by dividing by 2, I get 2 2's. If I take one of those 2's away by dividing by 2, I get 1 2. So it would stand to reason that moving down one more level to 2 to the 0 would mean I need to take this 2 and I need to divide it by 2, which is just 1. That's why 2 to the 0 is equal to 1. Now we're going to make it even more tricky. We're going to move from this step down to the next step by again dividing by 2. So we have 2 divided by 2, and we're going to divide by 2 again. So 2 divided by 2 is 1, and 1 divided by 2 is 1/2. We're going to divide by 2 again. 2 divided by 2 divided by 2, and then we're going to divide by 2 one more time. So 3 of the 2's gave me 1/2. Divided by 2 gives me 1/4. We're going to divide by 2 again. So we had 4 2's being divided. And we're going to divide by 2 again. We know that this part is 1/4, so dividing by 2 one more time would make this 1/8. Last time, and then we'll see if we can make this into a pattern. So 2 to the -4 would mean I need all 5 of these 2's. And I'm going to divide by 2 one more time. And that gives me 1/16. So let's look at some observations here. The first observation I want to draw your attention to is what happens if we start at the bottom and we continue to move up and up and up. What do you continue to do as the exponent gets larger and larger? So to move up, instead of dividing by 2, each time I am multiplying by 2. And why does 2 to the 0 equal 1? That's because 2 divided by itself, which gave me 2 to the 0, it took away all the 2's, equaled 1. Anything divided by itself is 1. what happened when you started using negative exponents? As soon as we switched over from positive exponents to negative exponents, our answers became fractions. Finally, why did this happen when you used negative exponents? Well, as we went backwards with the exponents, we had to continue to divide by 2 instead of multiplying by 2 when we moved forward with the exponents. So see if you can figure out what the pattern is when you have a negative exponent without writing out the whole table. Now it stands to be said here that when we are asked to simplify an expression that has exponents, we have to always get rid of any negative exponents. If there are any negative exponents, we have to actually rewrite them so that they are positive. And the process of doing that is called using the negative exponent property. Let's take a look at that property. In the property, we rewrite a negative exponent by making it positive and placing it in the denominator. If the exponent is in the denominator, we make it positive by placing it in the numerator. Okay, so that means that any exponent that is negative without a denominator or that's negative when it's in the numerator will become positive when it moves across the division line that makes a fraction. Now notice when it moved across the division line, the 5 or coefficient of the power stayed exactly where it was, and only the base and exponent moved across the line. Okay, here it is again. When we have it in the numerator, to make it positive, it goes to the denominator. I like to say that it crosses the line, so we change the sign. You can also kind of use the analogy of sometimes when we are angry or you're upset, you have to kind of change and get some distance before we can kind of change our attitude. So this -7 represents kind of a negative attitude, and once we change the perspective on it, its attitude becomes positive. If the exponent is found in the denominator, in order to make it positive, it has to become part of the numerator. Let's do a couple of examples for level 2. I have a to the -8. The a to the -8 is found in the numerator. So to make it positive, I have to put it to the bottom of a fraction, and that makes the 8 positive. And I have nothing left on the top to hold up the numerator, so I have to use a 1. For number 2, just the b is being raised to the -5th power. So in order to make it positive, it's going to move to the bottom of the fraction, or the denominator, and make it a +5, and on the top, the 2 will remain. For number 3, c to the -3rd is in the denominator, so in order to make it positive, it's going to move to the numerator. Same thing will happen in d to the -2nd. It's in the denominator, so to make it positive, it will have to move to the numerator. If it helps you remember that these are in the numerator, you can always make them into fractions.